Okay, here's our video on population percent problems, and today we're going to learn how to solve percent word problems related to populations of people. Okay, let's go on with our first example. In example 1, we have a school 60% girls, 40% boys, 20% of the girls wear glasses, 40% of the boys wear glasses. What percent of all students? Well, it's a little bit harder because we have the girls and the boys are not equal. So what we have to do is figure out what percent of the total amount each category represents. So for the girls, what we would do, for the girls, we would take 60%, which would be 0.6 times the percent of them that wear glasses, 0.2. I turn those into decimals, as you'll notice. So that's going to be 0.12. Then for the boys, they're 40% of the population, so I take 0.4, and I'm going to multiply that by how many percent of them wear glasses, 40%, so by 0.4, and that's going to give me 0.16 or 16 hundredths. Since my school is going to be made up of girls and boys, I'm going to add those numbers together to get 0.28. That's as a decimal, so what percent is that? Well, multiply by 100, and that will tell me that 28% of the population wears glasses. Okay, so you can see it's not halfway between. We can't just average the boys and girls together because more girls there's more girls in the school than boys. Okay, all right, moving on to example number 2. In example 2, what we have is the weight difference of different containers. The first container is 12% more than the second, and the third container is 20% lighter than the second. Now, we don't know what the second container is, so what we're going to do, since they're both based off that, we're going to give the second container, we're going to call that 100%. Okay, that's kind of like our base weight. We're basing everything off that, so since that's our base weight, that's going to represent 100%. So then I figure out that the first container is 12% more, so 100% plus 12% more, the first container is going to be 112%. Okay, then I know that the second container is going to be, or the third container, is going to be 20% lighter, so I'm going to do 100 minus 20 to get 80% for that. Okay, so then what I'm going to do is I'm going to turn that into a decimal, so that's going to be 1.12, and then I'm going to subtract by my 80% because that's going to tell me the difference between the two. So that's going to be 0.32. Alright, so that's our difference. Now, we want to know how much heavier, by percent, heavier it is in the third container. So what we're going to do is we're going to take our difference here, our 0.32, and we are going to divide it by the third container, that lighter container, because we want to know how much heavier it is, so we want to know how much that is based on the third container. So that's why I'm doing 0.8 here, because that's how much percent heavier it is. If I wanted to know how much percent lighter the third one is, then I would use the 1.12 down there. When I divide that, I'm going to get 40%, well, multiplied by 100, because we're finding percent change, so that's going to equal 40%. So that's going to be 40% heavier. Okay, now that would not be the same result if I wanted to find out how much percent lighter it is, but it is 40% heavier. Okay, so that's how we find those. So again, using a lot of our percent of change in there to find these answers. Okay, moving on to example 3. In example 3, this is a great question to see anytime you have different percents on different values and you want to see what the overall effect is. Because each percent is different and it is weighted differently, this is kind of weighting things, they're each going to have a different impact. The bigger the percent of the whole amount that it is, the bigger of impact it is going to have. So in this problem, what I'm going to do is I'm going to go through, I have 3 things. I have 20% increased by 5, 30% decreased by 5, and then 50% increased by 3. So those are my 3 amounts. So if it's an increase, that's a positive. If it's a decrease, that's a negative. So for the first investment, I'm going to do 0.2 times 0.05 minus her decreased here. It's going to be 0.3 times 0.05, and then an increase of 50. For the 50% was an increase, so it's going to be plus 0.5 times 0.03. That's going to give me 0.01 minus 0.015 plus 0.015. When I add those up, well, you can see I'm subtracting 0.015 and then adding 0.015. So that's just going to leave me with 0.01. We want to know what the increase was, is a percent. So again, we take that, multiply it by 100, and that's going to tell us that we have a 1% increase. Okay, a 1% increase in her overall investments. All right, so that's how we would do that. So we finding the percent of each section, and then you've got to debate if you're adding or subtracting them, as we've done in the last examples. Okay, now we're going to move on to example 4. In this example, we're going to have real numbers, not just percents. So when we're working with this is going to be a lot of work. Basically, we have an attendance at a concert, and the first night we had more people than we thought, and then the second night we had less. So we have to figure out, overall, did we exceed or under exceed the attendance that we wanted? Okay. So on the first night, let's start with the first night. We're going to go through some math here. So on the first night, we had 6,000 audience members, okay, and that was 20% higher than we expected. So the expected amount, this is going to be our base amount. So that's going to be our variable because we don't know what that is, and the other number is going to be what we're going to find. So if we exceeded by 20%, we will have our original amount plus 20%. So our original amount is 100% plus the increase in 20%. That means that we're 120% over what we thought. So that's the number we're going to use in our formula, and I'm just going to use my percent equation. So remember, that is percent times base equals part. Percent 1.2 times the base, x, equals the part, 6,000 members. Okay, divide both sides by 1.2, and that's going to give me x equals 5,000. Okay, which means if we do 6,000 minus 5,000, we had an extra 1,000 people. Okay, so that was good. Now on our second night, okay, we had 20% below the expected. So that's going to be 100 minus 20, which is 80%. So I'm going to do 0.8x equals 6,000. Divide both sides by 0.8, and we were hoping for 7,500 people. Okay, so that means that we were 7,500 minus 6,000, 1,500 people below what we wanted. So right away we know that we did not meet our attendance goal. Okay, the first night we were up 1,000, but the second night we were down 1,500, so we know that we did not meet our goal. But what percent do we miss our goal by? Okay, so to find our percent, we're going to do our percent of change formula. You do the amount of change. So remember, I'm just going to always do the positives, or bigger number first, so I end up with a positive amount. I already know it's a decrease. Over, now our expected amount. Now you might think the expected amount was 6,000 and 6,000, or 12,000, but it's not. The expected amounts are these amounts right here. So that's going to be 5,000 plus 7,500. So we had 500 people below what we wanted out of the 12,500 we were expecting. Okay, we only had 12,000 of the 12,500 people that we wanted. Multiply that by 100 because we want to turn it into a percent, and you end up getting 0.04 times 100, which is 4%. Okay, so we're 4% below expected attendance. Okay, so a lot of steps in this one, and you got to pay attention to what the numbers represent. Okay, so that's how I do that. We'll work on these tomorrow. Have a good night, and I'll see you then.